Hello all, welcome to Excel Academy. So today we are going to study on the topic that is problems on Z transform, and you can also see that before that we are going to discuss with one problem that we had done in the last class. We had missed some of the things over there, so let me clear that so that it would be really helpful for you, because I see once when I finish the video and I make sure that if I have left anything, I'll make sure that I'll clear it in this particular session without any hurdles. Okay, so my question that was in the last class was, that is x of n is equal to, just a second, x of n is equal to what I can say, that is minus u of minus n minus 1, that is what I can say, the plus, that is half to the power of n into u of n, right? Yes, just a second, plus half to the power of n into plus it is half to the power of n into u of n, right? So this was what my question that we had, right? So for this question, what I have to do is, I had got the resultant like this, right? What was my resultant? So my resultant was, that is equal to, I'll write the resultant now, that is your yes, it is equal to, x of z is equal to what? That is z into 2z minus 3 by, sorry, really sorry for the disruption, just a second. 2z minus 3 by 2, that is what I can say, that is divided by z minus 1 by 2 into z minus 1, right? We got this, right? Yes. So now what did we do? We just wrote the diagram with respect to the ROC. So I told my ROC is what? That is the concentric circle inside the ring. Why? It is because what I can say, that is yes, why it is because the, yes, why it is because it is a two-sided sequence, right? Yes, I'm sorry for the this thing. So it is a two-sided sequence, so therefore it must be a concentric circle, what I can say, inside the ring, right? So now coming on to here, so here for this, what is, I can say it as poles, the down part is poles and upper part is zeros, right? So I can say that, what I can say, this is what here 1 by 2 and 1. So what is here 1 by 2 and 1? So here 1 by 2 and 1, that is what, how did 1 by 2 and 1 come? That is what is, z is equal to 1 by 2. So that is z minus 1 by 2 is equal to 0. Z is equal to what? Z is equal to 1 by 2, right? Here z is equal to 1 by 2, and so therefore what I can say, that here it is 1 by 2, that I mark it over here and I'll write it as 1 by 2. I guess you got it, right? First what you have to do is, this upper part as zeros, right? This is zeros and this is poles. So what you have to do, so you're going to equate z minus 1 by 2 and z minus 1 to 0. That is, yes, z minus 1 by 2 is equal to 0, z is equal to 1 by 2. Yes, z minus 1 is equal to 0, z is equal to what? Yes, z is equal to, that is what I can say, the 1, right? So therefore here you mark it as 1, and then this is what I say it as poles, right? Now coming on to 0, so if you come to 0, so what is that going to happen for 0 says, so for 0 what you have got in the upper part, that is your z minus, what I can say, z into, that is 2z minus 3 by 2 is equal to 0. You got that, right? 2z minus 3 by 2 is equal to 0. So that is, now your z becomes equal to 0. That is, which z? This z become equal to 0. And then what I can say here, 2z minus 3 by 2 is equal to 2z minus, that is your 2z, just a second, I'm really sorry. It is 2z minus, oh god, yes, 2z minus 3 by 2 is equal to, what I can say, it is 0. And then now if I come upward, so I'll write next as what? That is your 2z is equal to 3 by 2, right? Your 2z is equal to 3 by 2, or what I can say, z is equal to, this 2 comes down and it multiplies with this 2, and you're going to get 3 by 4, right? So now your z is equal to 3 by 4. So now what I have to do is, I have to mark, what I can say, the z is equal to, that is your 0. This is z is equal to 0. The center point is 0, right? So this is, I'm sorry, Oh what? I'm sorry for the disruption that happened. So interruption that happened. So this is what is my circle, right? So here it is 0. So here it is 0, and then what I can say, you got it as 3 by 2. So 3 by 2 is what? Here a 3 by 2 is what I can say, that is 1.5, isn't it? Yes, your 3 by 2 is becoming equal to, that is your 1.5, and so therefore I am going to write it after 1. So that is, I am going to somewhere write it over here stating that it is, just a second, stating that it is 3 by 2. So therefore this is what is I have to do, right? So this is what is I missed it. So this is what is the correct ROC diagram. So I'll just explain it to you again, so please understand the concept clearly well. So I'll go up and show it to you what we did here. So here what we did over here was, so that is, I'll take another colors here. See, yes, I have another watercolor to showcase you people. Yes. Yes. So now here, this was the thing that we got, right? This is what z into, that is 2z minus 3 by 2 divided by z minus 1 by 2 into z minus 1. So what we have to do is, this down part is, what I can say, this down part is representing poles and this upper part is representing zeros, right? So what I have to do, I have to take the z minus 1 by 2 and z minus 1 and equate it to 0. So if I do that, so I have already done it over here. I'll do it over here. See, here z minus 1 by 2 is equal to 0. Here z is equal to what? Here z is equal to 1 by 2, and here z minus 1 is equal to 0, and here z is equal to 1. So what we got? We got two pole values. So my first one is z is equal to 1 by 2 and z is equal to 1. So that one you are going to construct over here, right? So that one you are going to construct over here. That is, you have already constructed, right? Yes. So now coming on to what I can say. Yes, I'll push it up. Yes. So coming on to what I can say, the zeros. So for 0, what I have to take? I have to take this upper part and equate it to 0, right? So if I say equate this upper part to 0, so I get it as my z is equal to 0 in the very first case. In the second case, I get 2z minus 3 by 2 is equal to 0. 2z is equal to 3 by 2, z is equal to 3 by 4 I get. So wherein what is a resultant? A resultant is for zeros, what I can say, it is z is equal to 0 and z is equal to, that is what I can say, the 3 by 4, right? So this is what is the resultant, and what now we got it as, I'll show, z is equal to 0, z is equal to 3 by 4, and we just plotted over here, right? We just plotted over here. Just a second, the diagram only got erased. I'll redraw the diagram again. So see here, this is what was my diagram, right? So I'll redraw the diagram in another this thing. Okay, yes. So let me erase this. So this is what is we got it, and how we have to plot the diagram is like, so what I have to do, please do make a list of your poles and zeros before writing the diagram. My poles is what? That is z is equal to, what I can say, the zeros are z is equal to 0 and z is equal to 3 by 4. My poles are z is equal to 1 by 2 and z is equal to 1, right? So let me draw the diagram in a clear manner. So I can say that I have to draw concentric circle inside the ring, and I have to what? I have to just make a highlight of just make a highlight like this, and then I have to plot 1 by 2 over here, somewhere 1 by 2 over here, and somewhere 1 over here, somewhere that is 1 over here, and once again I need to plot 3 by 2 over here somewhere, because it is 1 by 5, it lies in middle of 1 and 2, and here I need to plot it as 0, right? Here I need to plot it as 0, and so therefore that is why what I can say that this is what is my ROC, right? In the case of ROC, what you have to do is, you have to round mark for, what I can say, what you have to do is for 1 by 2 and 1, that is, here for poles, what you have to do, you are going to put a star mark for poles, that is, put a star mark for poles. That is what a star mark is. When you are going to mark for poles, you are going to make sure that you are putting a star mark for poles. This is for poles, that is when you mark it, right? And for zeros, you can see that it is your circle. Put a circle and state that they are zeros, right? and write the diagram big. Here I have written small. Please to write the diagram big and please to mark it in a clear manner, right? So this is what is we had made a mistake. Not mistake, I'm sorry, I'm really sorry. It is just we have missed it, and so we are going to just clear it out. So that is why I did this one. And then now coming on to my next problem. So these two problems are really very important. So and these problems are like somewhat, it is like just a condition problem, right? Let me take that particular problem and I'll take this color. Yes, so here, so now we are going to move on to the very next problem. That is, what is my next problem is, that is, it is like somewhat a kind of question with respect to condition. So therefore I take it as, that is what I can say, the x of n is equal to, just a second, yes, I'll take what is that is equal to x of n is equal to what, my x of n is equal to what, that is your 1 for, I'll just write it in a bigger manner. So it is 1 x of n which is equal to 1, that is 2 here, 2 that is minus 1, that is 1, and that is 0 for what I can say, this is for n is equal to minus 1, and this is for n is equal to 0, and here this is for n is equal to 1, this is for n is equal to 2, and this is for n is equal to otherwise, right? This is for otherwise, and this is what is the given question. And now what I have to do is, so I have to just solve this problem. So very first thing what I have to do for this problem is I have to take the x of z formula. So that is first step is your x of z formula. X of z formula is equal to, that is summation of n is equal to 0 to, I'm sorry, n is equal to minus infinity to plus infinity. So what I can say, that is x of n into z to the power of minus n, right? So this is what is the very first step. Please don't forget to write this formula without fail. And then now coming on to my next step, what I have to do, I have got some set of values of n over here, as well as I have got some set of resultants, right? I've got some set of resultants, right? So what I have to do is, first I have to substitute the value of n over here as well as here, right? So for all the values of n, you're going to substitute. That is how you do is, you're going to get it as, that is what, your x to the power of your first value of n is minus 1 into what I can say, z to the power of 1. Why z to the power of 1? Because this is minus n. So minus of minus 1 is what? Plus 1, right? Yes. So now it is once again plus. So my very first second value is x to the power of 0 into z to the power of 0, right? It is x to the power of 0 into z to the power of 0. That is what I can say, the 0, that is plus what? So that is plus, just a second, yes, yes, that is plus what? That is plus, my third value was, that is x of 1 into, that is what I can say, the x of 1 into, that is z to the power of minus 1 plus x of 2 into z to the power of minus 2, right? That is x of 2 into your z to the power of minus 2. So what the step did I do? I just substituted the value of n wherever n was present. So here there is an n present, right? Here there is an n present over here, this n, and for this n and this n I substituted all the values of n that is being given to us, right? So that is why I got this as resultant. So now next what I have to do is, I have to substitute here. So what is x of minus 1? So my x of minus 1 is equal to, the my given is 1, right? Given is 1. So for 1 into z to the power of 1 plus, that is what, my x of 0 is equal to 2 into z to the power of 0 plus my third one is what? My third one is x of minus 1, which I get it as 1. So that is 1 into z to the power of minus 1, that is plus what? So that is plus what I can get? I can get it as, that is here, what I can say, that is for your x of 1, you're going to get it as 2. That is what? 2 into z to the power of minus 2. Here what I have to do is nothing, guys. So first substitute these values of n over here. So here there is an n and here there is an n, right? So please to substitute n values over there, what is given to you. These four values you are going to substitute, that we already did it over here, right? That we already did it over here. What did we do? See here, we just substituted here also the value of n. This is x of minus 1. Here this is 1. So here it was n and n, right? We just substituted it, right? So here also it was n. Here is substituted with 0. And here also we substituted with 0. And here we substituted 1 over here. And here we substituted minus 1. So that is here z to the power of minus n. So therefore it becomes minus 1. And here also there was n. I substituted 2. And here also there was n. I substituted, that is minus 2. Because as it's z to the power of minus n, so I get it as that is minus 2. So then what is that going to happen is here for x of minus 1, what I get the resultant, that is given already. So if your n is equal to minus 1, so what is your resultant? Your resultant is 1. Here it is given, right? My resultant is 1. So therefore I substituted that 1 over here, right? And here for n is equal to 0, he told that it is 2. So here I substituted 2. For n is equal to 1, it is minus 1. So here I substituted minus 1. And for n is equal to 2, it is 1. So here I substituted what I can say, that is 1, right? Here it is 1. Just a second. For n is equal to 2, it is 1. So therefore what I have to do, I have to write it as 1, right? Yes, you got it? Yes. So this is what is my resultant. So now next what I have to do in the next step is I have to, what I can say, take this particular in terms of z. So if I take particular in terms of z, what I am going to get is, I am going to get this as z. So that is, this is 2z to the power of 1, which is equal to 2. Why 2? Because z to the power of 0 is 1. Anything to the power of 0 is 1. So therefore what is that is resulting is, you are going to get it as, that is 2. Right, here you're going to get it as, that is 2. So 2 into 1 is 2, right? Yes. So here it is z to the power of 1, which is equal to z, and z into 1 is z. And here it is z to the power of 0, which is equal to 1, and that into 2 is 2. Plus this is what I can say, the this is minus z inverse. Here see it is minus 1. So here it is being given minus 1. So this becomes is equal to what? That is, I'll write it. So this is minus 1. And this is not minus 1, this is minus, what I can say, this is z inverse minus 1, which is equal to what? That is z inverse, right? So this is minus z inverse. So that is plus z to the power of, what I can say, the minus 2, right? So this is what is the resultant. So your ROC is your entire z plane except 0, and that is what I can say, the infinity, right? You got it, right? Yes. So I'll clearly this brief you once again. So see here, this is what is the problem that we got. And here he has given certain values of n, right? Here he has given certain values of n, and what is that you have to do is, so what is that you have to do is, here you are going to just consider these values of n, right? Just to consider these values of n and the resultant this, and what you're going to do for this particular formula, that is what, x of n into, that is z to the power of minus n, what you're going to do is, you're going to substitute each and every value of n, right? So that is why I got it like this. So I substituted each and every value of n for this n that is associated with x, as well as this z to the power of minus n also. I substituted all the values of n and I got this resultant, and I got to know that this x to the x of minus 1, x of 0, x of 1 and x of 2 are holding some value that is being given here. So I got to know that for my n is equal to minus 1, the resultant is 1, that is written here. For my n is equal to 0, my resultant is 2. For my n is equal to 1, my resultant is 1. And for my n is equal to 2, my resultant is 1. So this is minus 1 and this is 1. So I wrote this over here, and when I multiplied this process, I got the resultant as this. That is nothing. You have x of minus 1, right? So here for n is equal to minus 1, what is that resultant? What is that resultant? So that resultant is 1. So which I wrote it like 1 here. That is 1 into z to the power of minus 1. And for all others also I did the same. For x of 0, what did I write? I wrote it as what? That is equal to 2. For n is equal to 0, it is 2. So that is 2 into z to the power of 0. For what I can say, the x of, for what I can say, that is the x of what? I'm sorry for the interruption. So this is x of 0, and for my x of, what I can say, the 1, what I wrote it as, that is minus 1 into z to the power of 0, z to the power of, what I can say, the minus 1. It is because It is because why? So for your n is equal to 1, so your resultant would be minus 1. Right now I took it, what I can say, that is x to the power of what? X to the power of, that is your, yes. Just a second, I'm sorry. Yes, so this is for my x to the power of, so that is minus 2. Yes, for my x to the power of, that is x to the power of 2, what I got? So for my x to the power of 2, I got it as, that is for n is equal to 2, I got it as 1, that is so 1 into z to the power of minus 2. So this is what is I substituted over here and I got this particular resultant. So this is what is for this kind of problem. So there is another problem of this kind, so I'm going to teach that other problem also now. So please do concentrate on that other problem. So my other problem is given by, that is equal to what? Yeah, this thing, that is your x of n is equal to, just a second, I'm going to reduce this. Yes, that is what my x of n is equal to what? So my x of n is equal to, that is here something different, so that is 0 for n is less than 0, and here it is 1 for, that is your 0 is, that is what I can say, lesser than or equal to 9, that is what? So that is 0, that is lesser than or equal to n, so that is lesser than or equal to 9, and here it is 0 for, that is n is lesser than 9, right? Yes, so this is what is the question, and what I have to do is, here I have got that only one condition satisfies because all others are 0, right? So that is why I need to take only that into existence. If I take my x of z formula, what is my x of z formula? My x of z formula is equal to what? My x of z formula is equal to, that is summation of what I can say, that is your n is equal to minus infinity to infinity, that is what your x of n into z to the power of minus n, right? You got it, right? So now I have to substitute over here. So what is my range? So my range will become equal to, that is starting from 0 to 9, because this 0 is lesser than or equal to, that is n lesser than or equal to 9, means that what it means? It means that your range is from, that is 0 to 9, right? Your range is from 0 to 9. So therefore what I have to do? So I have to take my range starting from 0 to 9. So this particular thing means that your n is between 0 to 9. So therefore it is starting from 0 and ending at 9. So therefore this is what is, and your x of n is 1, so that is given over here. So that one you are going to write, so no need of writing 1, it is, you already know that. So that is why I can directly write it as z to the power of minus n. So now next step, what I have to do? So what I have to do, my next step, that is equal to, there is one formula for this particular. So this formula is not the formula. So what happens is, there are different formulas for alpha to the power of n. But what we have to see the summation with respect to the particular alpha to the power of n formula. So let me write that. So I'm going to scroll up. See here. So there are two summations we have seen. That is for here n is equal to 0 to infinity, that is alpha to the power of n, right? And another one we saw that here n is equal to 1 to infinity, that is alpha to the power of n, right? But now we are going to see another summation, that is one is different summation. What is different summation? That is n is equal to what is that? N is equal to 0 to, that is capital N plus 1 alpha to the power of n formula. So what is that formula? It is, that is 1 minus alpha to the power of capital N divided by 1 minus alpha. So this is what is the formula that you see, right? So now here what is n? This formula is what? That is this formula. I'm sorry guys, this is minus. So I was, yes, this is n is equal to 0 to n minus 1 alpha to the power of n formula is what? That is 1 minus alpha to the power of n divided by 1 minus alpha. So that is, and also which is equal to n. For this one the condition is, that is alpha should not be equal to 1, and for here your alpha should be equal to 1, right? So now let me do according to this formula. So according to this formula, if I take, so what I'm going to get is, so here it is, what I can say, the n minus 1, right? So the n minus 1. So as your summation is the 0 to 9 summation, so if you want to get 9, what you have to do? It is 9 is 10 minus 1, right? Yes. So that is why you're going to get it like this. So what you have to do? So you're going to write it as, that is summation of, that is n is equal to 0 to 10 minus 1, or I can say it as 9, that is z to the power of minus n, which is equal to what? That is 1 minus, that is z to the power of minus 1, that is whole to the power of 10, right? 10, that is divided by what? That is 1 minus what I can say z to the power of what I can say the minus what I can say the minus n, right? What I can say, that is minus 1. So why minus 1? I forgot to do that step over here. So this one, what you can do, you can remove n as a power. So that is, I told you that z to the power of minus 1 whole to the power of n. We have already done this one, right? Yes. So this one you can write like this. So here I am writing that is z to the power of minus 1. So now what is that going to happen is I multiply numerator and denominator by z to the power of minus 10. So my resultant would be is equal to what? That is z to the power of 10 minus 1. So what I can say, that is z to the power of 9 into z minus 1, right? Z minus 1. So how is that? If I multiply that, what I can say, if I multiply, that is z to the power of minus 10 to both the numerator and as well as denominator. So therefore I get it as, that is z to the power of 10 minus what I can say, I get it as, so that is what I can say, the z to the power of, that is, so here I can get it as, that is z to the, just a second, so I'll just clear it to you. So this is what is z to the power of, so that is this is z to the power of 10. Okay guys, I'll clear it in next session. So I just have a small I just need a small clarification. So this is, you are going to multiply with z to the power of n here and z to the power of n over here. So that is what you are going to get a resultant as this. So here you can see that it is z to the power of 10. So that is, here you get it as, that is z to the power of minus 10. So therefore wherein you are going to get it as, that is z, here your what happens is, if you multiply, that is z to the power of minus 1 into z to the power of 10. So you are going to get it as a to the power of m into a to the power of n is equal to a to the power of m minus n. So that is minus 10 minus 1 would give you z to the power of 9. So here it becomes z to the power of 10 itself. So here what you get, so in the denominator, that is in the denominator you get it as what? That is your z to the power of 10, that is minus, that is z to the power of 9. So how you can write? You can write it as, that is z to the power of minus 9 into, that is z minus 1. So this is what you are going to get it in the denominator. So right, I'll check with in the case of numerator and I'm going to tell you, right? So this is what is the resultant that you get, and if I consider for the poles and zeros, so you can see that for the poles and zeros you can see that it is z to the power of what I can say, it is having 9 poles. So that is a z to the z minus 1 is equal to 0. What I can say, z is equal to 1, and that is z to the power of 9, which is equal to what? Yes, z to the power of 9, which is equal to 0. And also you can see that that is your z to the power of what I can say, 10 minus 1 is equal to 0, and z to the power of 10 is equal to 1. So if you z to the power of 10 is equal to 1, and now you have some poles, like you have 9 poles, and what is your what I can say, the 9 you have 9 poles over here in the center. So that is, and then your z to the power of 9 is equal to 0. So therefore you are going to put it, you are going to mark it in the place of 0, and you are going to tell that it has 9 poles and your another one pole is 1. And for zeros, what is that going to happen is, if you consider z to the power of n is equal to r e to the power of j omega. So that is, if you consider r e to the power of j omega, so for a z to the power of 10, what happens? So this 10 will get divided by omega. So if you consider your omega as 360 degrees, so 360 by 10, which is equal to what? That is what I can say, 36 degree. So therefore your for your zeros, your zeros occur at every 36 degrees, right? So I'll just explain it to you clearly. So just a second guys, I'm really sorry for the inconvenience. So let me go. So your poles, what is your poles? Your poles are, that is what, you have 9 poles, because z to the power of 9 is equal to 0. So just mark it over here and state that is, just mark it over here and you are going to state that, so that is equal to, yes, you are going to state that is equal to 0. So this is, you are having what, you are having 9 poles, right? So you are having 9 poles, and what is that going to happen is, for zeros, I told you that it is, you have an angle with respect to each and every 36 degrees, right? For each and every 36 degrees you are going to have a what I can say, the angle, right? Yes, I'll erase this. Yes, yes. So you're going to draw a circle like this for each and every 36 degree. So therefore you're going to get 1, 2, 3, 4, 5. Just a second, you're going to write 9 like that, right? 5, 6, 7, 8. So here also you're going to write 1. So like that you're going to write 9 like this. So you're going to get it 9 like this, and you're going to draw a dotted line over here, and it is 9 pole, and here you're going to mark it as 1, right? This is what is the resultant that you get, and it is the entire ROC plane. So you're going to shade the entire ROC plane, right? Yes. So now coming on to this particular problem, I'm going to just re-brief you once again. So your question is that, so that is your x of n is equal to what? So that is your x of n is equal to, what I can say, it is 0 for n is equal to 0. As n is less than 0, this is 1 for 0 is lesser than or equal to n, lesser than or equal to 9, and then this is 0 for n is lesser than 9, right? So that is your n is greater than 9, and you can see that in this question. So this one only gets satisfied because all others are 0, and you can see that for 1 it is the condition, that is 0 is lesser than or equal to n, lesser than or equal to 9, that is your n is starting from, that is 0 to 9, right? Your n is ranging from 0 to 9. So for 0 n is ranging from 0 to 9, that is x of n into, that is z to the power of minus n, which is equal to what? You are going to get z to the power of minus n. Why? Because your x of n is 1, so therefore you directly get it as z to the power of minus n only, right? So now what is that going to happen is, so here you are going to consider one formula, that is with respect to n is equal to 0, summation of n is equal to 0 to n minus 1, that is alpha to the power of n. This formula you are going to consider. What is the formula? It is 1 minus alpha to the power of n divided by 1 minus alpha. So that is what we did over here. So what did we do here? We took n as a power, that is we got it as, that is z to the power of minus 1 in whole to the power of n, right? So we took that and we are going to substitute with respect to this formula. That is, what is the formula? 1 minus alpha to the power of n. So this capital N is what? 10 over here, because what is 9? So 9 is as per n minus 1, it is 10 minus 1, right? Your 9 is as per 10, it is that is as per n minus 1, it is 10 minus 1, right? So that is why we took here it as 10. And what did we do? So that is, you are going to get it as, that is 1 minus z to the power of 10, that is what I can say, divided by 1 minus z to the power of minus 1, right? 1 minus z to the power of minus 1, that is your alpha, right? This is alpha to the power of capital N. So now what did I do is, I just multiplied the numerator and denominator by z to the power of 10, and I got this resultant. And now I just got to know about my poles and zeros. So what is my pole? My poles are, that is z to the power of 9 is equal to 0, and your z is equal to 1, and I marked it up here. So you can see that I marked it over here, that is this one. I'll rewrite this again clearly. So what I have to do is, your ROC is the entire z plane. So first what I have to do is, I have to draw this particular like this, and first I have to what? Mark it here 0. First I have to mark it over here, and I have to show that this is 0, and this is having what? So this is having 9 poles, right? I need to write that this is having NINE. So that is 9 poles, and you can show that here 1 also you can showcase, this is 1, and then what is that going to happen is here you get it as z to the power of 10 minus 1. So this particular, so that is z to the power of, so that is 10 minus 1 is equal to 0, and that is z to the power of 10 is equal to 1. So therefore what is that going to happen is, yes, z to the power of n is equal to what I can say, that is here, what I can say, that is z to the power of, so that is your re to the power of j omega, right? J omega, and what happens to z to the power of 10? So this omega gets divided by 10, and so therefore here if you divide 360 by 10, if you consider omega as 360 and if you divide it by 10, you are going to get it as 36, and so therefore here what you can see that, so this particular 36, so that is, so this particular what I can say, the 36 degree is your resultant zeros, that is your zeros will be present at 36 degree, each and every 36 degree. For each and every 36 degree your zero would be present like this. So 1 2 3 4 5, that is 6, that is 7, that is 8, that is 9. To have 9 you are going to write line like this with a what I can say dotted lines, and this is what is your ROC, and you are going to shade the whole ROC, right? So 0 will be present for each and every 36 degrees. So for first it is 36, then plus 36, then plus 36, then plus 36, like that it goes on till 360 to be present for each and every 36 degrees, right? So that is what is the resultant for this particular question, and this is what is for today's class, and in the next session we are going to see through. So that is the another problem with respect to this particular, and thank you.